Welcome everyone to another C++ video, and today we will talk about concepts. So I'm sure you guys have worked with templates before, and templates is a source of weird errors and also unreadable code sometimes. Concepts was introduced to simplify that, and hopefully by the end of the video you will know why. So let's say that you are writing a generic template called add. It's a function template, and the goal of this function template is to add any element to a container. So you create this function and you test it out in a vector and everything works. But if you now test it out on set, so let's call it set of int, and let's do this. This will fail, as you will see right now, because there is no pushback method defined in the set. So the obvious choice would be to duplicate some code and instead of pushback call insert. And as soon as you do this, you will see that this does not work either. And the reason is that whenever template function starts matching the exact definition to instantiate, it just compares the function declaration, not the function body. So when this add gets instantiated or compiled, it will just compare the function declaration signature, and in this case both of the function declaration signature are exactly the same, so it really doesn't know which one to compile, and you will see a compilation error. This is not a runtime error, this is a compilation error, and it exactly says, it's hard to know what's the error, but it says redefinition of template class, and exactly means the same thing, that the compiler does not know which function are you trying to call, because to the compiler both of them look the same. So that's not the solution, as you can see. Now one way to solve it is to probably change the function signature here, so that will make it compile, but we have a better way to do it. So let's use concepts now. So here is a concept that I've defined, and this part of first of all, it has this weird syntax as well, but the more you use it, the more comfortable you will get with it. So the has pushback is called the name of the concept. So the concept is called has pushback, and the body of the concept that is inside this curly braces is called the requirements clause, or just requirements for short. So how this really works is, and I'm missing a semicolon here, so okay, so how this works is that you have essentially given a set of requirements and you have named the requirements as has pushback, and that is just a concept. So to make it work, what I can do is I can just replace this column, do here is, instead of this type name, I can just add this concept here. So as soon as I add this concept, I have essentially changed the function declaration signature, and now it compiles. So when you called the first function, it now sees two different function signatures, and since we have applied the concept to the first one, the first vector kind of matches the concept and gets instantiated. When the second gets called, it might try instantiating the first template and it will fail, and then it will check the second one, it will pass, and the second one will get called during runtime. So that's one way to do it. The second way to use concepts is you can keep the function declaration as before, but you can just have instantiate the concept like this, and I'm missing a requires clause here. So as soon as do requires here, it should compile again. And you can do either of the two. You can either use it like this, or you can put hashback here. And the good thing is that this thing is compile time, is evaluated compile time. So you can also do static assets on this. So what I can like this, and it should evaluate it true or false. Right now it evaluates to true, but if I do something like set, it will evaluate to false. Yeah, so you can do a lot of cool stuff like this. Like you can check at compile time if something is true and do stuff here. So I think that's a good introduction to concepts and why we want to use it. And as you can see, it clears the code a lot. It makes it much more readable, because anyone reading this function knows that whatever the function argument is, it has a pushback method. It's much more clear than just reading like this. So yeah, I think that's good enough for the first introduction lecture to concepts, and in the next lecture we will do much more cool stuff with it. So see you in the next lecture.